Hypothalamus artificial intelligence. Digital transformation powered by real-time autonomous and intelligent algorithms. Presents its solutions for optimization of energy efficiency in oil and gas industries, refineries operation optimization, oil supply chain optimization. The oil and gas supply chain is made up of 4 links: upstream, midstream, downstream and retail. The links are connected by multimodal transport networks. The oil industry includes global processes of exploration, extraction, refining, transportation and marketing of petroleum products. The largest volume products in the industry are fuels, natural gas, fuel oil, and gasoline. However, petroleum is the raw material for many chemicals, including pharmaceuticals, solvents, fertilizers, pesticides and plastics. The table, elaborated by IBM, shows a resume of the optimization solutions for oil and gas enterprises. Optimization solutions in the transport chain of petroleum products can be classified by their hierarchy: strategic, tactics, and operating. Several of these applications will be discussed below. The current computational power allows to model detailed the supply chain, considering individually all the systems that compose it. This allows to visualize all the existing bottlenecks, and that affect the maximization of economic gains. Oil refining optimization includes a generic model that can serve interchangeably to plan the crude and/or biomass refining processes that may be spatially detailed in all units used in the production of refined products. Hypothalamus AI considers the production process as a union of 2 processes: product transformation, conversion of barley into commercial products, through processing units, and energy transformation, processing of auxiliary industrial services required by process units, and which are consumers, or energy producers, in the service units. To optimize energy efficiency, the first step is to optimize the integrated supply chain, since this is the part of the production process that consumes more economic resources. High oil ref includes a generic model that can serve to plan, at the aggregate level, the crude and/or biomass refining processes. The level of aggregation is fundamentally related to the nonlinearities associated with this type of process, but not with the level of detail with which it is possible to represent the production processes, which can be spatially detailed in all units used in the production of refined products. The objective of optimization is to determine the production plan that meets the demand for refined products, according to an offer of available crude types during the planning period. Industrial services optimization is the complementary model to the production model, aimed at optimizing energy management in industrial plants that include large-scale industrial service plants, such as refineries, petrochemicals, oil and gas production, and oil and gas transport. These services often include self-generation, cogeneration and the exchange of energy with the interconnected electricity system. The objective of the model is to minimize the consumption, or cost, of the energy required by the industrial processes, supported by the industrial services plants. The industrial services system is coupled with the production process model to holistically optimize the transformation of crude oil into refined products. The model high oil ISO can be integrated with the industrial production model high oil ref or can be coordinated. The integration involves a single optimization process. The coordination implies 2 processes. First step, the optimization of production using high oil ref, and second step, the optimization of the high oil ISO model, having as a border condition the results of high oil ref. The simultaneous optimization of both industrial production and energy conversion is related to polluting emissions of gases and liquids, associated with increasingly demanding environmental control laws. High may integrate complex industrial process models to redesign the power supply system, according to the new power technologies. This type of model includes the simulation of polluting processes to determine the optimal mixture of fuels, in accordance with environmental regulations. Vessel scheduling optimization supports the programming of collection and/or distribution operations of products via maritime ways, in tankers and barges. Its relationship with refineries is direct, since it is common that refinery operations must take into account port operations, to coordinate the arrival of vessels with crude oil, and the departure of vessels with refined products. It considers restrictions for delivery and load time windows, distribution of capacities on ship, loading and unloading capacity at the docks, draft capacity of the spring, speed of movement of ships, tanker weight to draft ratio, and synchronization of filling, or emptying, of storage tanks. 7th. Planning and scheduling of bulk port terminals. The objective is to minimize the terminal operating cost, considering the system environment, which may include the fuel cost of ships. Managing bulk ports and ships becomes part of the industrial process, since it defines the supply of raw materials and the distribution of finished products that are related to industrial operations. Depending on the specific case, it must be coordinated. The arrivals with consumption in industrial plants, the departures with production in industrial plants, and the storages level with the output of material. The optimization may affect the industrial process's speed and the ship's speed. When it is necessary to make decisions about the displacement of the vessel, it is of fundamental importance the correct modeling of the consumption of energy, which has a nonlinear behavior, with respect to the engine speed of the vessel. This constraint can be included in the mathematical model, as well as the modeling of tidal movements when entering or leaving ports. Hypothalamus artificial intelligence is the creator of artificial brains as the new form of augmented artificial intelligence. Thank you very much for your attention.